Okay, hello everyone. This video we are going to finish the homework problem 12.129. Okay. In previous video we finish. Okay, we identify a neutral axis and also the moment of inertia. And yeah, we haven't answered the problem. Okay, we still have to calculate one physical parameter Q. Okay, and for the Q, for the Q, we need some, yeah, I think it's some explanation okay, so the problem want us to calculate the maximum allowable, determine the maximum shear force or with the condition max allowable shear stress. Okay, but yeah, at the very beginning of this problem, I say the maximum of shear stress in beam is always at the neutral axis. Okay, neutral axis. So right now we want to calculate the if we want to calculate the shear stress in beam, we already have the moment of inertia, and we also have to calculate another important parameter called Q. Okay, this Q, okay, Q is the position of Y. Okay, so in the previously we say in previous we say, in previous video we say, okay, if your Q is above the neutral axis, so calculate the Q above the point. Listen once again. If your point of interest, if your point of interest is above neutral axis, so calculate the Q above the point. Okay, if your point of interest is below the neutral axis, calculate everything below the point. So for example, this point, if we are this is our point of interest. Okay, this point of interest is above the neutral axis. So we have to calculate the Q above the point. So that means he's here. We have to calculate the Q here. Okay, and the point of interest here is below the neutral axis. So calculate the point, calculate Q below the point of interest. So that means Q is here. Okay, so the point of interest will affect the Q. So actually, Q is a function of Y. This is very important. Q is a function of Y. Okay, so this is a Y-axis. Okay, this is Y-axis. Yeah, the Q is a function of Y. This is very important. So the point of interest will affect the value of Q. Okay, and right now we want to calculate the maximum. We want to know we have to do something with maximum shear stress, and the maximum shear stress is always at the neutral axis. There's no question at the neutral axis. Okay, so that means our point of interest is at the neutral axis here. Our point of interest is right on the neutral axis. So in this problem, because we are dealing with the maximum shear stress, so our point of interest, interest, is on the neutral axis. Okay. So if a point of interest is just right on the neutral axis, you can calculate below. So you can calculate above or below the point of interest. That's both are okay. Okay. If the point of interest is right on the neutral axis, you can calculate Q above the point of interest or below the point of interest. Now the value will be the same. The value will be the same. Okay, for the Q, okay, I should say Q above equal to Q below. Okay, but I would say this if your point that's only happen when your point of interest is on neutral axis. Don't forget this condition. If your point of interest is right on the neutral axis, your Q above and below you will have the same answers. Okay, so that's the concept of this problem. Okay, so because max shear stress maximum in B is always at neutral axis. So we can calculate Q We can count it above or below. For this problem, yeah, the neutral axis is here. So when we're trying to calculate Q, we want to calculate Q above or Q below. Um, in this problem, below is better. Why? Because let's check. If you want to calculate Q above, you are dealing with this shape. Okay, yeah, don't forget the neutral axis is here. So the shape is like this. The shape is like this. Okay. If we calculate Q above, the area will look like this. The areas look like this. If we calculate based on the below, okay, what's the shape you are dealing with? You are dealing with this shape. Okay, and which one is better? Which one is better? Which one is better? Which one is easier to calculate? Okay, this is easy. Okay, this is kind of, I think compared to this is difficult because this is just too rectangular. And this is not that rectangular, so this is a composite area. This is a composite area. This is a composite area. So if you count, because the Q above and Q below, you have the same answer. Okay, so we choose this one because it's much easier to do the calculation. Okay, of course you can choose calculate Q above, you will have the same answer, but it's much more difficult because it's a composite area, and if you use Q below, calculate Q below, that's a two rectangular. That's much easier. Okay, okay, so let's calculate the Q. We use the Q below. Okay, Q below. And the Q is equal to summation AI YI. That's called first moment of area. So okay, so let's say okay, well, the neutral axis here, so we are going to calculate the area below the neutral axis. Be careful. So what's our area? So what our area is here. Okay, maybe I did it. I should did this. Okay, did this. This one did this. Okay, so what's our area? Okay, we want to calculate Q below. So it's summation AI YI. What's our A? Yeah, you have to be careful. The A is here. The A is here. A is here. A is here. Okay, A is here. A is here. A is here. So what's the area? Okay, it's 25 times 45.83. Be careful. Therefore, that's is 25 times 45.83. That's your area. Okay, here, yeah, because we calculate everything below the neutral axis. Yeah, because our point of interest is at the neutral axis, so we can calculate either below, either above or below the neutral, everything above or everything below the neutral axis. But if you choose above, we are dealing with complicated shape, composite area, more difficult. So we choose the calculate Q. We calculate everything below the neutral axis. Okay, because right now point interested on neutral axis, so calculate everything below the neutral axis, and because it's much easier to calculation. And the area below the neutral axis is 25 times the 45.83. Okay, be careful. And what's our y? Okay, the y, okay, for the calculate Q, the y is the centroid to the neutral axis. Centroid of the area to neutral axis. Okay, centroid area. Okay, what's the area? What's the area? You have to be careful. What's the area? It's right now. It's the yeah, the black slash part. So that's the centroid of the shade area. Okay, the centroid of the shade area. The centroid of shade area. So where is the centroid of shade area? Is not this. No. Centroid of shade area is here. Centroid of shade area is here. Okay, centroid of shade area. So here is 45.83 divided by 2. Yeah, be careful. Yeah, you calculate Q is summation AI YI. What is our Y? Okay, it's the centroid of the area of interest. In this problem, shade area, the centroid of a shade area to your neutral axis. Okay, so your neutral axis here, and neutral axis is here, and okay, let me see. So, okay, so yeah, so here is 45.83. So this must be also be 45.83 divided by 2. So it's 45.83 divided by 2. Yeah. So, yeah. Oh, sorry, I forgot the prefix. I forgot the prefix. That's also very important. So times point. Okay, this is our A. So that's our Y. I is 45.83 divided by 2 times 10 to the power minus 3. That's our Y. And this shade area for in area 1 and it's identical to area 2. So we just double. Okay. So what's the value of the cube right now? Okay, so what's the value of the cube? Okay, let me see. Do we have the right? A is okay. So I think let me check my equation. Yeah, it's right and it's right and okay, and the times 2. So after using calculator, you will have the 52.51 times to 10 to the power minus 6, and for the Q is meter cubic. Okay, so we finally got our Q, and we already have the I, we have the Q. Okay, so I think we can answer the problem. Okay, so what's the maximum shear force if we have the maximum our maximum shear stress is 56 megapascal. Okay, so let's use this formula. Okay, so shear stress is 56 times 10 to the power minus 6 megapascal equal to, okay, the maximum shear force, we don't know. That's what we want to calculate. So our Q is 52.351 times 10 to the power minus 6. And okay, and our I is 2.6366 times 10 to the power minus 6. Okay, and our TT is the thickness here, So our point of interest is here. So what is our T? Our T is 25 and 25. Don't forget 25 and 25 because this is our cross section is here. So your T is this part and add this part. So it's 25 times 2. Yeah, be careful. So this is 25. Okay, so this is 25 times 2 times 10 to the power minus 3. Okay, this is also very important. Yeah, our T is the thickness. But right now our thickness, yeah, it's not only this part, we also have this part here. So you have 25 plus 25. So you have 25 times 2. Okay. So actually this is a very easy calculation. So after using your calculator, you will find your V max. Okay, I just write my final answer here. Your V max. Okay, you use this formula to calculate the V max. Yeah, I think it's easy. Okay, so your V max will be equal to 140.6 and unit is kilonewton. Okay, so if our constraint is maximum shear stress is 56 megapascal, our maximum shear force is 140.6 0.6 kilonewton. Okay, so actually this problem, I won't say it's hard, but we have to calculate the I, and also have to calculate Q, and also have to determine the thickness. So it's all right to yeah, so but it combine everything together, so it's become a kind of very difficult. Yeah, especially you need to understand how to calculate Q. Yeah, the problem is Q because right now our point of interest is on the neutral axis. And yeah, so if your point of interest is on the neutral axis, you can calculate Q above the neutral axis or Q below the neutral axis. You'll have the same answer. But this problem, if you choose Q above, you will have a composite area. That's kind of more difficult. Yeah, you still can calculate, but it's kind of more difficult. So we choose a Q below because a Q below is a very simple two rectangular shape. That's much easier for the Q calculation. And Q calculation is summation AI yi. So just determine the area of each part, and determine the distance between the interest area, the centroid of interest area, distance of the distance between the centroid of interest area to the neutral axis. Yeah, I think this is the most this will confuse most students. Okay, this I think most students will make mistake on this. I believe. Okay, this is yeah. Be careful for this, and also the AI also will also make a mistake. Okay, also makes a mistake because Q is a function of Y, so you need to be very careful. Okay, if you have different, if you are doing a different point of interest, your Q will be very different. You will see, because for these two examples, you see the area is so different. Okay, in this one area is here, in this one area is here. The area will be very different, and also they have different distance, distance of the central of interest area to the neutral axis. Okay, in this composite area, you need to also calculate. Yeah, it's really not that easy. Okay, for this one. Okay, but I demonstrate an example of this before in a textbook example. So this is yeah, take really a long time. Okay, even looks like very simple, but it's not easy. So okay, so this is the problem. Demonstrate problem for the 12.129. Okay, 1209. Okay, so for the shear stress calculation, yeah, it's really not that easy. Okay, especially for this Q. Q is easy to make mistake. Q is very easy to make mistake. Be careful. Okay, so I just stop video here. See you in another video. Bye bye.